All right, Science 10s, this is lesson CA8, multivalent ions / compounds. So in your notes package, make sure you are flipped to that and have your periodic table out as well. It's important to be able to look in your periodic table for these ones. So find your way to that. So I'm trying something, I'm not on my smartboard right now, I'm on a tablet, so this could really go sideways quickly. I'll do my best. So at the top there it says multivalent ions / compounds. So there's kind of a new word in there. We know what ions and compounds are, but the word multivalent we're going to learn. So some ions form more than one stable electron configuration. So in other words, they can form ions of different charges. So we call these multivalent ions, meaning they can have different, so multi meaning many, or multiple, multiple valence configurations based on it. So multivalent ions typically include the transition metals. So in your periodic table, if you're peeking at your transition metals, you'll see that what we're talking about here is definitely happening with lots of the ones that are in the transition metals. So those are groups 3 through 12. So on the periodic table, the more stable or common ion is always written at the top of a dotted line. So in your periodic table, you can find your way to iron. Ooh, is it working? No, it's not going to let me pen right now, so let's go back. So find your way in iron to your in your periodic table. Ooh, look at, I can do a different color. And so iron is atomic number 26. It's kind of in the middle. It's in group 8. Group 8 there. So iron 26. So we've already learned about all of this stuff. Whoa. That's going on here. We know what all of this stuff is, but we see down here, there are 2 different charges that iron can form. So it means that iron can form a 3 positive or a 2 positive ion. So the one that's more common is always written at the top there. So the 3+ ion is more common since it is found above the dotted line. So whichever one's the top one. If you don't have any information, we always, oh my gosh, sorry, this thing is impossible to write on and look at my screen at the same time. We always assume the most common. But quite often you'll have pieces of information that will tell you which one it actually is. But again, if you don't have a piece of information, you assume the most common or the one that's at the top. So to name compounds that contain multivalent ions, we actually need to specify which of the ion charges we're actually talking about. So we use Roman numerals in order to indicate the charge on the ion. So for the iron example, the way that we would write this when we're naming, so Fe3 positive, when we're naming it, we're writing out the full word. So what we do is we do iron, and then in brackets, so there will always be those brackets beside it, in brackets, the Roman numeral 3. And if we were talking about iron with a 2+ charge, we would say iron, again, with 2, Roman numeral 2. And we would specify that we're talking about iron 2. And you need to do this if we are naming iron, you need to do this. So you need to use, it's called the stock system, that allows you to differentiate between what iron we're actually talking about or what ion species is actually within our formula unit. So in order to name them, well, I'll scroll over with this. In order to name them, so naming ionic compounds containing multivalent ions. So if you get a piece of information and you need to name it, sometimes you'll be given information and sometimes you kind of need to deduce it the way we are here. So it says work backwards from the charge on the anion. So you'll notice that none of our negative charges, an anion is a negative ion charge, is multivalent. It's only our positive charges or our cations that are actually multivalent. But anything that has a negative charge, your anions, again above the staircase, our nonmetals, will always have the same charge. So we use the charge on our anion to determine the charge on our cation. Our second step is write the name of the metallic element in full, so something like iron. And then step 3 is add Roman numerals for the charge of the metal ion in brackets. And same as our binary ionic compounds that we had before a couple lessons back, we write the name of the nonmetal with an IDE ending. So those ions that are already in your periodic table with that ending of IDE. So here we have Fe2O3. So we're given our formula unit, we're given our chemical formula for this. So we know that it's going to be iron, but looking at iron, we see that it's multivalent, so it's going to have either a 2 or a 3 there. And we know that we're going to take our anion, change the ending to IDE. So iron something oxide. So we need to figure out now. We don't just assume in this case that it is necessarily iron 3, because we actually have pieces of information that'll tell us for sure if it's iron 3. So since we have O3 here, that means we have 3 of the anions. So we have 3 O2 negatives, an O2 negative and an O2 negative. So overall, net charge from our anions is 6 negative. We know that this overall compound, this overall formula unit, needs to be neutral. So we know that our number of negative charges needs to be equal to our number of positive charges. So since it says Fe2, we know that we need to have 2 irons. So in order to have 2 irons, they need to have a 3 positive charge to come up with a total charge of 6 positive. So it says, why not Fe2 positive? Sometimes this is a really common mistake, is people will slot in a 2, and they'll say iron 2 oxide because there's a 2 there, but it's not actually based on the subscript. Now I've really created a mess. What if I go like this? No, it doesn't erase. I think I can undo, but I can't do it right now. It's not iron 2 oxide, because if it was iron 2 oxide, so if we have 2 iron 2s, that's an overall net charge of 4 positive, which is not equal to that 6 negative. So it will not balance the 6 negative from the oxygen. So it's actually iron 3 oxide. Oh, so how is the compound named? Well, I named it right here. So iron 2, 3 oxide. So Fe2O3, we determined iron was 3 plus, so the name is iron 3 oxide. So this doesn't tell us about relative numbers, it just tells us about the charge on the iron. So a couple practice questions there. This is a super short lesson, hopefully. So we have Ti, which is titanium, and O, which is oxygen. So titanium is atomic number 22. So looking at that, you see titanium can be 4 positive or 3 positive. So we need to use our chemical formula to figure out which it would be. So we know we have a Ti, and we have an O, and another O. Oxygen, our anion, always forms a 2 minus. It is not multivalent. It doesn't form a different ion species. So we know that in total our anion is contributing 4 negative charges. So our cation, which is the titanium, needs to contribute 4 positive charges. So actually in this case, we know it's 4 positive right away, because again, these 4 positive charges need to balance out the 4 negative charges from there. So the way we would name this is titanium, and 4 is IV in Roman numerals, titanium 4 oxide. Again, that IDE ending, because we're talking about the ion of oxygen, which is that 2 negative. So next example is PbO2. So Pb is lead, it's atomic number 82, if you need to find it. So we know Pb. oh, oh, lots of oxide here. I don't know why it's so repetitive. Um, so lead, if you look up lead, it can be 2 positive or 4 positive. And so looking at this, again, our anions in total are contributing a 4 negative. So we know our cation, we're told there's, again, if there's no subscript there, there's a 1, so we just have 1 lead, so it needs to be 4 positive. So we know that it must be 4 positive to balance out the 4 negatives that are contributed by oxygen there. So our naming, lead 4, oops, oxide. And so again, we're following the same IUPAC rules as before. Things are spelled right. There's no capitals. Again, Roman numerals for your charges. So make sure you've got, up to 5 down for Roman numerals if you don't know them already. So that's naming based on a formula, but we also need to look at steps for writing formula for multivalent ionic compounds. So this is actually not too bad. It's basically the same as what we would have done for binary ionic. So it says determine the charge on each atom. So in this case, if it has a Roman numeral, that is telling us the charge on the positive or the cation species. Balance the charges by changing the number of each atoms using subscripts. So just like when we did binary ionic or simple ionic compounds. And again, make sure that you have it to your lowest whole number ratio. So I said previously, I don't really like this, whatever it was called, drop and flip or whatever way they had it, but you can do that. I usually tend to. Just cross it out here. Let's just cross everything out so I can go through the actual question. So it's saying nickel, nickel with a 2+ charge, because again, that Roman numeral bracket is telling us that it's nickel with a 2 positive charge. Nickel can also form, if I have my periodic table out, it can form a 3 positive as well, but this is telling us that this is the 2 positive. And chlorine, we know chlorine will always form a 1 minus. So right now I have 2 positive, I have 1 minus. So I know that I'm going to need another minus charge, negative charge. So now I have 2 minus, 2 positive. So now overall those charges will be balanced out. So writing the formula, Ni, again, I just needed one of those nickels. So you don't put a little 1 here. We don't need to do that. You don't put a 2 here since it says 2, nothing like that. That 2 just indicates the charge on the ion. So NiCl2 is our formula for nickel 2 chloride. Next one is copper 1 oxide. So copper atomic number 29. Copper can form a 2 positive, which is the more common charge, but it can also form this 1 positive. So we know Cu is just a 1 plus. Oxygen, we've done it a couple times now. Oxygen with a 2 minus. So we have 2 negative charges, 1 positive charge. So we need more positive charges. So now I have 2 positive charges contributed by copper and 2 negative charges contributed by that 1 oxygen. So writing our formula, Cu, our subscript is just the numbers of how many of those particular ions I need. So Cu2, because I needed 2 of those coppers, and oxygen, I just needed 1. So you don't need a subscript there. You don't want a subscript. Please don't write a subscript. So this is our formula for copper 1 oxide. Again, I can't stress this enough. This 1 only tells us the charge on the copper. You don't want to start putting a 1 here instead of a 2. It's nothing to do with the relative numbers, just the charge. So chromium. Chromium is Cr, telling us it has a 3 positive charge. This is phosphorus. So looking, phosphorus forms a 3 minus. 3 positive, 3 minus. All right, it balances with a 1-to-1 ratio. So it's just CRP. So writing the formulas is really similar to what we did in, again, those simple ionic compounds. But now we just need to worry about what's happening within those brackets with that Roman numeral. So another note, you do not put Roman numerals if the cation is not multivalent. So ZNO is just zinc oxide. If you look at Zn, zinc, atomic number 30, it only forms a 2 positive charge. It doesn't form more than one ion species. So you do not put zinc 2 oxide. You only do this if it is multivalent. So peek at the questions that I assigned from this lesson and have those done and sent to me ASAP. Thanks, guys.